Hi, this is Alex from devstories.eu. Computer Vision Deep Dive, episode 19 of 20. Traditional video games render worlds by drawing millions of tiny, flat triangles. The newest revolution in computer vision scraps triangles entirely, rendering reality as a dense cloud of millions of overlapping, glowing mathematical blobs. This is Radiance fields, 3D Gaussian Splatting. A real estate agent walks through a house recording a standard smartphone video. You need to process that raw footage into a fully navigable, photorealistic 3D virtual tour with dynamic reflections and lighting. For a few years, the standard approach was neural radiance fields, or NeRFs. A NeRF maps space using an implicit neural network. To generate an image, it shoots a mathematical ray through the scene and queries the neural network at hundreds of points along that ray to ask what color and density exists there. It produces beautiful results, but querying a deep neural network for millions of pixels is severely slow. 3D Gaussian Splatting abandons the implicit neural network. Instead, it uses an explicit point cloud-like structure. The pipeline starts with a standard structure from motion algorithm, analyzing the smartphone video to track the camera position and build a sparse 3D point cloud of the house. The algorithm then replaces every single point in that cloud with a 3D Gaussian. You can think of a 3D Gaussian as a semi-transparent colored ellipsoid. Each Gaussian holds a specific set of parameters. It has a center coordinate in 3D space. It has a covariance matrix, which dictates its scale and rotation, stretching it into a flat disk or a long cigar, depending on the geometry it represents. It has an opacity value. Finally, it stores color data using spherical harmonics. Here is the key insight. Spherical harmonics are mathematical functions that encode color directionally. When you look at the Gaussian from one angle, it might reflect a bright window. From another angle, it shows the dark texture of a floorboard. This is what gives the final virtual tour its photorealistic, view-dependent lighting. The initial point cloud is messy, so the system enters an optimization loop. It projects or splats these 3D Gaussians onto a 2D camera view to render an image. It subtracts this rendered image from the actual photograph taken by the real estate agent to calculate the error. The algorithm then uses that error to update the parameters of the Gaussians. During this optimization, the system actively manages the Gaussian population. If a blob grows too large and overlaps too much detail, the algorithm splits it into smaller pieces. If an area with complex textures needs more resolution, the algorithm clones existing Gaussians to increase density. If a blob becomes completely transparent or irrelevant, the system deletes it. Because the final scene is entirely composed of explicit data points, rendering it is exceptionally fast. The graphics hardware just sorts the ellipsoids from back to front and blends their colors to form the final image. The breakthrough of 3D Gaussian splatting is proving that a chaotic cloud of explicit mathematical blobs can capture complex light and geometry far faster than a dense neural network. Thanks for listening. Take care, everyone.